Hello everyone and welcome to this fifth video that will be part of a series about the Go programming language. And today we're going to look at other ways to create, actually more formally, declare and initialize variables. In fact, so far we have not yet talked strictly about what initialization and declaration of variables is. And to this video we're going to do exactly that, as well as introduce type inferring. So the first thing that we want to introduce is what does it mean to declare a variable. So you are probably familiar with the concept of variable as a sort of a box with a label on top that contains a certain value that you can access throughout the program, you can change, you can print out, and so on. But when you create one, there's actually different things that you do. And now let's see exactly what the difference between declaration and initialization is. So declaration is just basically introducing a new name inside the program. Roughly, actually, it's a little bit more than that, because in some languages there's what is known as a preprocessor, and well, it's not super strict. But for this video, for example, here, it is a good enough definition for you to understand what declaration is. So when we declare a variable, we want to say to the compiler, okay, we are going to introduce this new name inside our program that we will use in the future. But we're gonna just say, okay, this is a new name that we will use, but we do not necessarily assign a value to it. And initialization, on the other hand, is the process of assigning a value to a variable. So why did we care about separating these two processes? Well, because we don't actually need to assign a value to a variable each time we create one. We could as well just declare a variable, for example var str of type string, and actually do not put anything inside of it. So say, do not specify anything about its value, and the compiler would just be fine. Of course, remember that Golang, if you do not use a variable inside the program and you declare it, it will throw an error. It will say, you're not using this variable, so you don't need it, comment it out or remove it. So compiling the program as is now, of course, would throw an error, but actually this saying here that we wrote is completely correct in Golang. And what we did here was just declare the variable str, meaning we're telling the program that we're going to use this name inside the program, but we did not yet assign a value to it. And so we understand that we can actually declare and initialize values on separate lines. Basically, we can declare it on one line and then initialize it just after. So we could initialize, for example, this variable to hola. Then if we try it with font to print out str, let's see what we get. And you get hola. As you can see, the program works, and we basically first just declare the variable. So we said, okay, this is the name that we're going to use, and then we said, okay, this name is equal to that string. And then now the program knows that str basically is equal to hola as a string. Okay, so this is the first thing that we should have said about variables. Now, as you know, Golang is a strictly typed language, meaning that when we declare a variable, it is very important that we include the type in the declaration. Because if we, for example, forgot about saying that this was a string and we did this, then look what happens. We will get syntax error, unexpected new line expecting type. So it is very important that we specify to the program that the str variable is of type string. But now let's see what happens if instead we said var str is equal to hola. And now you should notice something weird. Okay, but we said that Golang is a strictly typed language. It's important that we specify the type, but we now didn't specify the type in this expression here, but we still got a variable of type string. In fact, if you're not convinced, let's try to print out the type using the %t formatting verb that we introduced in the last video. And let's see what it gives. So go around, output go. String. So we got a string, but we didn't tell our program that this was a string. It kind of, it basically just inferred it on its own. And this is the concept of type inferring. So also, the name is pretty suggestive. It should suggest that this means basically deducing the type of a variable from an expression that doesn't explicitly tell it. In fact, that is what inferring means basically in English. And what we did was precisely an example of type inferring. So we declared and initialized a variable at the same time without specifying its type, and then by setting it equal to something on the right, then the Golang compiler understood what type was it just by looking at the value we initialized it to. So we can do this also with integers. So if we, for example, we said int1, equal to 55. Then we go here and we substitute it with int1. Now let's see what happens. Go run alpha.go. Oh, actually, sorry, yeah. Well, now you see, also with integers, it basically infers the type by the initialization that we did. So now with these two things that we said, you now should know that you can declare and initialize variables at different parts of the program, so you do not need to do it at the same time. And you can also declare variables without specifying its type, but only if and only if you're going to initializing it at the same time too. Because if you're going to just declare a variable and then not initialize it, and if you don't specify its type, it will throw an error, as we saw above. So for example, doing this var number would not be okay, because we're not also initializing it. We're just declaring it, and when we declare something, we need to strictly specify its type. So speaking again with type inferring, there's also another way to infer a type of a variable, and that is using the colon equal sign. This actually, if you've ever programmed in Pascal, and maybe you like vintage programming language, you should like this because this looks a lot like variable initializations in Pascal. But basically, the syntax in order to declare a variable using the this sign here is the following. So let's write the syntax. So you have your variable name here. Then you have this sign here, which is actually in mathematics, it is often used as a definition sign. So you define this as, and then here you have the value. And in this case, also, you do not need to specify the type because it will be inferred naturally by the compiler. So let's make an example, maybe number. And basically, we're going to define it to be equal to 76. Now, let's try to prompt printf, first the value, and also the type of it. Let's see what returns. And we got 76 int. So as you can see, this also works, and the type gets inferred. So also another thing that we should cover is also how to declare more than one variable on the same line, because often you want to declare many variables, but you do not want to use many lines of code, especially when, for example, sometimes it can be good and it can save lines of code as well as it can also help readability. So first, let's suppose that we want to declare many variables of the same type. So for example, we want to declare a variable a of type integer equal to 1, another variable b of type integer equal to 2, then c equal to 55, and then d equal to minus 178, minus 178, and then e equal to 768, for example. Okay, so as you can see, this took 5 lines of code, and also it is not super beautiful to look at because we're repeating the var and int keywords, the var and int tokens a lot of times, and it just looks untidy. So how can we fix this? Well, we can just declare all of them on the same line, and now we can do that, and we can do it in the following way. We can say a, b, c, d, and e int equal to I forgot the values that we put. For example, let's say that we put it equal to 1, 2. I think the first one was 55. Then I forgot the other one, but never mind. And so this is actually as equally valid. And now if we try, for example, to print all of these out, so A, B, C, D, E, and then run the program, you get all of them out. So as you can see, you can also declare variables on the same line like this of the same type. But what if they're not of the same type, but there's still a lot of variables that would occupy a lot of space, and maybe you want to declare them on the same line? Well, then you have to use type inferring. You cannot specify the type strictly. And to declare more variables of different types on the same line, you can either use the operator of the definition operator that we introduced before, or using var equals with type inferring. So for example, the first way would be var, for example, a, b, c, d, e, and then we set the first one equal to an integer, 17, the second one equal to a boolean, true, the third one equal to another boolean, false, and then the last two ones are strings. So for example, string 1 and then string 2. So let's see what happens if we run with the compiler our code. The code prints out just fine and it works. The other way to do this now let's comment this line out, would be to use the definition operation, and that is the following. In this case, we need to omit the var keyword. I'm just gonna include the definition operator, which is this one. It's colon equal, and then we set the same values as before. So 17, true, false, string 1, and then string 2. And this also works, as you can see. And so these are some ways that you to declare variables on the same line. And again, as I said before, this can be useful in some cases in which basically defining a lot of variables on different lines could impact readability of the code. And at this stage, probably, if this is your first time programming, you don't understand quite yet what readability of code means, but you will see what that means once you start building bigger projects. So lastly, you can also declare variables in block using these parentheses. Actually, if you remember on the Golang playground that we used in the last videos, you can also basically group together package inclusions using these braces. But of course, we will cover that once we cover packages, import, and the package structure for Golang. For now, let's see how you can declare variables in block. So the way you can do it is pretty simple. You just use the keyword var, as usual. Then you open some braces, and you can declare your variables. So you can declare them and initialize them. You can, for example, declare them of another type and initialize them, declare them of another type and just declare them without initialization. And this is actually useful because if you recall before, you could just declare on the same line in block variables of the same type. Because if you try to declare variables of different types on the same line, you cannot do that because you necessarily had to use inference operators such as var equals without the type in between, or the colon equal operator. With this, on the other hand, you can also just declare variables of different type in block, and this is also, and you will see that this might come quite in handy sometimes, and it can help with readability. And now the last thing that I want to talk about variables and variable declaration is that of identifier rules. So we already said that an identifier is basically a arbitrary name that you give to, for example, a variable. Now, a variable needs to obey some rules, of course. For example, let's try to declare and initialize using the colon equal operator a variable of equal to 2ab. Let's set it equal to 22. So let's try and print this out. So print 2ab. Let's see what happens. And syntax error. As you can see, it gave us a syntax error because we're not allowed to start variables with numbers. And so we empirically, you could say, experience one of the first rules. So the first one is that a variable name, so an identifier, cannot start with a number. Not only that, but also a variable name must necessarily start with a letter or an underscore character. So the underscore character, this one. And so this is why the previous variable gave us an error. Now let's try to, for example, call it %ab. And let's do the same. And as you can see, it also will give us an error. So if you run it, it will give an error because we started the variable with a non-accepted character. So always remember, use that your variable needs to start with a letter or with the underscore character. Another important rule is that your variable cannot be one of the reserved keywords of the Go language. This will be clearer once we introduce some constructs of the Go language, such as, for example, if, else if statements, and so on. But for example, if you try to declare a variable if, and you set it equal to 23, then if you try to print it out, it will give you an error because this is a reserved keyword. We will see what if statements will do when we will cover them. As you can see here, you cannot declare a variable named if. And then another important rule that you need to obey is that, of course, variable, and I'm sure you've already probably convinced yourself of this because you saw that in these videos we only declare variables without spaces, and variables cannot contain spaces. So in order to emphasize, for example, spaces in a word, you can use other cases. You can use some variable declaration formats. So formats to emphasize spaces that are good for readability. I will present some of these notations to you that you can use in your programs to increase the readability of the latter. So the first one is camel case that I'm sure you're familiar with if you use JavaScript in, for example, for web development. And camel case just works as following. So for example, imagine you have a phrase such as my name is, but then camel case basically transforms as follows. So it compacts the word, and then it will leave the first word unchanged, and then after each space, the first letter of the following word will be capitalized, but just the first one. So for example, my name and then is. To accustom yourself better to this convention, you can, for example, consider I live in, I don't know, London. Okay, if you convert this into camel case, this will become I then live in London. And this is another example. Another very important naming convention is also snake case, which basically just eliminates spaces. For example, in the last case, I live in London, by adding a underscore character in between. So this would become I live in London. As an exercise, you can try to transform these phrases into camel and snake case. But really, the way in which you declare your variables, the identifiers that you give, is pretty much up to you. These are only some rules that actually increase readability, but you can make your own if you really wanted to. So with this said, I think we've said enough about variables in this video, and in the next one we will start talking about floats.